Good evening, and welcome to the stream. Tonight, I think I'm going to be doing some game development topics, specifically looking at some Win32 programming in C++, and see what we can do with that. I've learned quite a lot over the years of programming in C and C++, and I just thought I'd share a little bit of that with you. The Win32 programming is pretty interesting. Let me see if I can get some of this stuff ready to pop up on the screen here. Okay, bear with me. Excuse me. Having trouble trying to get my source to work here in OBS. Oh, ta-da! I did it. Okay. Hope that looks good. Visible. Okay. What we're looking at is Visual Studio 2022. And the project I have open here is just a simple Win32 okay, yeah, you can see my mouse in there. This is just a basic Win32 application, and I'm going to go through it and explain a little bit about it, and then I'm going to execute it and show you what it does. As you can see, it says a complete basic Windows program creates a window and waits for you to close it is all it does. It doesn't display any graphics or anything like that. This is like a starting point for doing a game. And this would probably lean toward doing a game in graphics, probably either with GDI, or you could use you could do OpenGL too, or DirectX, Direct 3D now is what they call it, I think. Not so much with OpenGL, because with OpenGL you would want to use a windowing library called GLFW, which abstracts all of this stuff I'm fixing to show you out of the way and makes it a lot easier to create a window in any operating system, because behind the scenes GLFW does all the code for whatever specific platform you're on. For like the Mac stuff, it'll do the code that you have to do to create a window in Mac. It'll do all this code on Windows that I'm getting ready to show you behind the scenes. So you just do some simple GLFW commands and voila, you have a window with a lot less code written, basically. But this is a beginner type. Let me get that box out of the way. This is kind of like the beginner framework for doing games, or for creating a window would be the thing. Using Windows code. This is what you will learn first. So we've got some a define right here called Win32 lean and mean, and what that does, it just tells the compiler that you don't want to use any of that Microsoft Foundation class libraries or anything, because that's just a bunch of complicated stuff that you don't want to mess with just trying to do a simple game or something. but we do need a Windows header that includes a lot of important stuff that we need for Windows, doing Windows programming, and Windows X header. We need that too. It's another one that includes a lot of stuff that we'll need. Standard input-output header includes things to do input and output. I don't think we're doing too much input and output in this particular program, but that's what you would need standard input output for. The math header is used for, probably not used for much in this one. I think they just included it in this example because the tutorials that I was following later down the line, they do things that needed the math header file. And then we just make a define for this particular application, because we're going to create a window class, and we just put its class name into, this is called a it's a constant, and I can't remember the term they use in Windows programming from this, but this just defines a constant called window class name, and the class name is WinClass1. So wherever we use this constant in the program, it's going to evaluate to this name. And then we set the width and height that we want the window to be. In this case, 1024 by 768 pixels. And this little area of code right here is, I always, whenever I would follow one of these tutorials to do a simple window, they would always make the window width and height, but they wouldn't set it to a certain position on the screen, so it always showed way up in the top left corner of their monitor. And I just wanted it to show right smack in the center of the monitor. So how in the world do you do that? Well, I researched that and learned that you can do it with this code right here. Now this is kind of the long way to do it. I'm going to change this right now and show a better way to do it with only 2 lines of code. So I'm going to change this to almost a constant integer. Position X is equal to get system metrics, and what we're getting is what's going on here? There we go, we need that right there. See it. What we're doing here is we're getting, when I say get system metrics, that's a Windows API function call, and I'm telling it, give me what the x-axis size of the monitor screen is. And then I'm going to divide that by 2, and then I'm going to subtract the width, which is the size of our window, and I'm going to divide that by 2. And I'll explain this a little further in just a second. And then I'm going to do the same thing for the Y position, which is just the width and the height, X and Y width and height. And this call right here gets me what the height of the monitor is. And I'm going to divide it by 2 and subtract the height of our window we're creating, and we'll divide that by 2. So I don't know if I can show you this, but pretend like this whole screen right here is the monitor screen. And we want to create, and say that monitor screen it's way bigger than 1024/768. And we want to create a window that's 1024/768, and we want it to appear right in the center of that window. Well, to determine where the upper left corner of that 1024/768 size window is going to appear within the monitor screen, we have to take the width of the monitor, divide it by 2, and the height of the monitor, and divide it by 2. So that'll put us right about here. And then we take the 1024 and divide it by 2 in the height, and divide it by 2, and that will, wherever that number lands at, will be the upper corner of where we want that 1024/768 window to appear. And I'll show you how that works when we get to the point where I'm going to run this thing. Okay. Every Windows program has to have a messaging handler function. It's a callback function, and this is it right here. L result callback. It returns an L result, and it's a callback function. And you can name your callback function anything you want to. A lot of people will call it the window proc, short for the window procedure, meaning that's the message handler. Well, I call mine Robert F. Butler. Robert F. Butler was the name of my father and my older brother. My father was Robert F. Butler Sr., and my brother was Robert F. Butler Jr. They have both passed away. As my father passed away in 2003, and my brother passed away in 2008. So this is my tribute or memorial to them. I always name my Windows message handler Robert F. Butler. So that's why that's called Robert F. Butler. Okay, and what this message handler does, when Windows is a event-driven operating system. So if you, just look on the screen right now, it's not doing anything but displaying Visual Studio for me. If I move the mouse and move the scroll bar, I'm moving the scroll bar on the mouse to scroll this window. When I do that everything you do in Windows, like moving the mouse, clicking the mouse, doing a left click or right click, sends a signal, a message to the application that you're doing that in. Like in Visual Studio, when I click and drag the mouse on a word in the Visual Studio editor, inside that message handler for Visual Studio, it's executing code in the message handler to make that highlight for that word right there. So every time you do something in Windows, that's an event. And this is where these events are handled in a program is inside this callback function. Excuse me a minute. Get choked up talking so much. Okay, so in here we have to declare a couple of variables. This is a paint struct data type called PS for paint struct, and then we do an HDC, which is a handle to a device contacts, and I'll explain that shortly too. Probably won't get to the point of actually using one of those things, but we do use it right here in the WN paint message, because these are the messages. The message gets sent in from the win main function, which you'll see in a little bit. The message, when something happens in your application, the message gets sent to the message handler in this variable right here. And this is just the handle to the window that sent the message, which would be the window we're making eventually. These other two parameters that get sent contain other information that we're not going to use right now. Okay. So what you do is you do a switch statement on this message to figure out, and you put in here which messages you want to handle. Right now, all we're handling is we're not actually doing anything with this message, but right here you could do some kind of initialization right before the excuse me. You could do initialization stuff right when the window opens up, like in a little bit I'll show you another program that when it creates the window it actually plays a sound, and it's pretty interesting. And we put the code in here to play that sound. Every window you create has to process this message, WM paint. Whenever you do something with the window, like if you resize it, move it around, click off of it so it doesn't have the focus anymore, that sends a WM paint message, because you have to do something and repaint the window. So that's where we would do a begin paint function, passing in the handle to the window and that paint struct. And this creates a handle to device contacts for that window and puts it in this HDC. And then you can use that HDC to actually plot pixels on that window or do some other stuff with the graphics device interface, GDI, which is too much to go into right now, but it's pretty cool stuff. And then when you're finished doing that, then you just do this in paint. Well, we're not doing any graphics right now. What we're doing, you have to do this though, because what this does, it paints your window. So if another window goes in front of it, if you had anything in that window, it would disappear from that other window going in front of it. But then when you would give the focus back to your window, it would repaint it and straighten it back out to what it was before. Basically, that's what it does. The WM destroy message gets sent when you've clicked on the X to close the window, or you've written code that listens for you to press the escape key and then that sends a message to the destroy of the WM destroy, and causes the post quit message to execute, which basically just shuts down the window and the program quits running. And then any other messages that get sent to your message handler that you don't handle or don't care about, they just get taken care of by this default window procedure that the system uses. And it just kind of like tells it, oh, well, ignore those messages. We don't care about those. So that's what that does. And that's the end of that message handler function. Now we come to the win main. If you're familiar with programming, you know that every program has to have a main function. In a console text only type of program, you would have a main function just called main. But in a Windows program, when it runs on the desktop and has a window, you can see it has a win main function. But this is the first function that gets executed when you tell the program to execute, to run. And we have a few parameters that get passed, and these get passed in by the system. The first one is the H instance. That's just the handle to this actual program, the whole program. The H previous instance used to be used in the old early Windows, but they don't. Before Windows was multitasking and multi-threaded, you had to really watch how you tried to use the system. You had to be aware of other programs and everything. It was a pain. But this doesn't, it's not used anymore, so we don't use it for anything in here. It just has to be there. This next line, if you executed this program on a command line and you gave it some other parameters after the name of the program, they would be inside that variable, and then you could use that variable in your program and see what somebody passed into the program. Might be variables that tell it to do something special when it starts up or something, and you could parse that and use those in your code to accomplish those tasks. Okay, then we got to create some variables. We create a win class variable because we have to create a structure that's of type window class EX, and we call it win class. And then we have to fill the structure in with, this structure consists of these other variables that we have to give values to tell it what kind of window we want to make, and some other information. Well, first of all, we tell it what the size of the actual structure is. So it's of class win class EX, so we tell it, well, the size of this thing is the size of one of these structures. Duh. This next line is the style of the window. We want the window to be able to respond to double clicks. We want it to own its own device contacts. We want it to be horizontally redrawn and vertically redrawn. This line right here tells what event handler it needs to send messages to. You saw that earlier, Robert F. Butler. These two parameters here that are 0, I forget what specifically that is. Let's see if I can tell. change it. I think it has to do with something with the menu and something else, and we're not using menus in this window, so we just put zeros in there. This is the H instance from up here. It's just the instance of this particular program. Here's an interesting line. This tells what icon is going to appear up here in the Windows upper left corner. And we're just using the system, the normal system application icon. And we're going to tell it what kind of cursor. You see when my mouse cursor is over here and it looks like an arrow, that's what IDC arrow is. It's just this normal cursor. So in our window we're creating, this is the cursor, mouse cursor. It'll look like this. This line tells the window what its background is going to look like. And I know I've got to set the white, but I'm going to change it to black. Oops. We'll change it to black because that looks better really when it actually happens. This variable right here, I forget which one that is, but it just null. Don't have to worry about it. Right here, and I don't know why that's in there like that, because this should be this constant variable we defined earlier. Kind of a mistake I made. This icon down here is a smaller version of so this first icon is the one that appears in the upper left corner of the window. This icon right here is the one that will appear on the taskbar when the window's running. And hopefully we'll be able to see that. I don't know if I can get my whole screen in here, but I'll try. Okay, so we filled in the window class. Now we're going to register the window with the operating system. So we have to register the window, or the window class we just created before we can create the window. So we do that like this, and the reason why we use this if statement, we're saying if register class EX when class does not work, that's what that exclamation point means. It means if not, meaning if it didn't work, then return 0 and the program ends and nothing happens. So if there's an error, that doesn't work. But if it does, then it goes on to this next line and creates the window. And then again, we use that same kind of logic. We're testing to see if it didn't work. If it doesn't work, then we don't want it to do anything else, and we just return, and the program stops right there. But if it does work, it goes on and continues executing these lines of code. And I've got to change these two because I changed those earlier when I simplified that code up at the top. So this is the function we use to create the window. We pass null to the first one because this particular window is a parent window, and it doesn't have a parent, so the parent will actually be the desktop, and you just pass it null to tell it that this window is going to appear inside the desktop. So, and then we include the window class name. And then this line right here is the title in the title bar of the window. This right here, WS, overlap to window, tells it that we want a regular window that can function like a normal window and overlap other windows. Now this is interesting right here. This code right here is really the way this create window EX function is written right now. It does need this code, but I can comment out these two and put one little thing in here. I can put a pipe symbol and a WS visible flag right there. And what this does, it just puts these two flags together. It says we want a regular overlapped window, and we also want it to be visible. So we don't have to, so if we don't include this WS visible flag, then we have to do these two lines of code to actually show the window, or it won't show up. So I'm commenting this out and I'm putting that in there, and the window will appear without having to do this extra code in here. So it's some of the little quirks of Windows programming. Okay, so we've created our window, and once it's created successfully, it goes and does this while loop. Now this while loop just keeps running and running and running and sending messages. It's this block of code right here will just keep running and running and running. And what it does, it just keeps the window open and sends any messages to its message handler that you do in the window, like click in it or move it, resize it. It's going to send messages. Or if you click on the X in the upper right corner of the window, when it's running, then it sends that message to the WN quit, the WN destroy message to the message handler, and tells it to, hey, we're out of here. When that happens, this loop ends, and this is executed and returns. And I have no idea what's in WParam at that point, but you have to do this to get out of that program and make Windows happy about it. So, with all that said, we're going to run this puppy now and see if it actually works. Since I changed a bunch of code, it might not work now. Cross your fingers. And it should appear, it should make a 1024 by 768 size window appear in the middle of the monitor. Before I do that, I'm going to try to see if I can capture the whole screen. Excuse me. So if the screen goes black here in a minute, you'll know why. I'm changing stuff around on the fly here. Might have to put another. Okay, I'm going to have to use a different capture. And that's going to capture the whole display. Well, that looks funny. Yeah, I don't know if that's going to work or not, friends and neighbors. Does that look better? probably not fitting right. Let me see if I can remedy that. It's going to look really weird until I get it right, so just bear with me. Looks like it's going off into infinity. Let's see. I think that did it, friends and neighbors. So now we should only see, yeah, here we go. We can see my entire Windows screen now. I hope I'm not violating any things, any copyright things by displaying my whole desktop. Maybe not. Okay, now we're going to run this thing, see what it does. Ta-da! I'm going to minimize Visual Studio. This is the window I created, and as you can see, it's right smack in the middle of the monitor screen. And you can see the center of this window is exactly halfway down the monitor screen on the X, or actually that's the Y, and it's exactly halfway, or actually I think it does this. Okay, we took the width of the screen and divided it in half, so right there is the halfway point, and that right there is the halfway point on the Y2 going up and down. And then we did the halfway on the window. We subtracted half of this window from that screen, and then half of the height. So that position X and position Y is right here in this upper left-hand corner, and that's where it displays the screen at, and it positions it perfectly in the center of the monitor window. And this will work on, that code will work on any monitor because it's using this system call to get the size of whatever monitor is hooked up to that computer. So it'll work on everybody's computer no matter what size monitor they have, no matter what the resolution is. That's the cool thing about it. Okay, so that's how you do a basic window in Win32 programming. Now the only way we can close this window is by clicking on Spread X up in the upper right hand corner, and bingo, it's closed and the program stops running. So that's, and let's look at see how many lines of code. We had like a little less than 150 lines of code just to display a window with a black background. No graphics, no game, no nothing. So you can imagine how many lines of code you'd have to have. You'll have quite a bit more, and you will have quite a bit more files. I only got like one file in this program, the source CPP file. In a real game, you're going to have a lot more source files, and you're going to have resource files, and you're going to have header files. So it gets really big, fast. So basically that's Win32 programming, a basic your basic Win32 program in C++. Now let me see, I can show you another one using OpenGL that draws. Oh, wait a minute. We got to do this one. Let's see where. Give me a chance to find it here. I got a bunch of these. Okay, here's the sound demo. This one's really cool. This program, this is another Win32 program. And you see this one has a few other files. It has a resource header file. It has a resource RC file. And it has the main CPP file. And it's basically got a lot of the same stuff. It's got some other different things, like we have to include that resource header file. And what this resource header does, it defines menus that are going to be in the window, and it defines some sound resources. Excuse me. And it also defines an icon and a cursor resource that we're going to stick in to that when we're building that window class. And this icon T3DX is going to be displayed up in the upper left corner of the window and down on the taskbar. And the cursor crosshair is going to be what the mouse cursor looks like. It's not going to look like this. It's not going to look like this arrow. It's going to look like a crosshair, like you're aiming something. Just to show you that you can change those particular resources. And all of this stuff, all these files and everything get compiled into the executable. And I'm not going to go through here and explain every bit of this. It's basically kind of the same stuff. And here's, when you click on a menu, that's an event and a message that gets sent to the message handler, good old Robert F. Butler, the message handler. And this one plays a sound when the window first gets created. And then it sits there and waits on you to do something. So when you click on a menu, if you click on the exit menu, it just closes the program down, shuts it down. When you click on the About menu, it displays this message box that tells you about says menu sound demo. And it has an OK button and an exclamation point icon in it. When you click on the Energize menu, it plays this Energize sound. When you click on the Beam, it plays a beam sound, like a beam me up, Scotty. When you click on the Teleport menu, it plays this teleport sound. When you click on the Warp, it's actually called a quantum warp teleporter. It plays this warp sound. It's pretty wild. Then you have the paint thing again, and then whenever you shut the program down, either from the exit menu or from the X at the top of the window, it calls this destroy message, and it has to execute this to purge any of the sounds out of memory. And that's the end of that. And here's the window procedure. And this is a different way of building up the window class. Before in the other one, I did it all inside of an initialization block using curly braces, but you can do it like this too. Just do the win class variable and then the dot and tell it which member of the structure you want to initialize, because this structure has this many variables in it. automatically, because that's what a structure of Win class EX has. It has all these variables in it, and you have to fill them out. And again, this is where we just tell it the size, and then we tell it the style of the window. And there's the pointer to the window procedure handler. And these 2 0 things were just some kind of CLS extra and window extra that's not used anymore. I forget what in the world those things are, but probably some kind of command line thing and window handle thing. And this is the instance of the application, and here's where we're loading the icon, and there's that icon T3DX, and you're going to see what that is in a minute. It's pretty cool. And the crosshair, we're doing a black background. This right here is how we load the menu. You know, before this was null, because we didn't have a menu. But now we have a menu. It's called Sound Menu. Oh, I have to show you this in a different file. Hang on a second. I can't open that RC file in Visual Studio because it'll totally mess it up. And I want it to just stay a plain old text file like it is. So I have to open it up in another text editor. So give me a second here. Gotta navigate to where it's at. Right here, and it's sound demo, and it's this guy. So this is what the resource file looks like. What it does, it's assigning an identifier for this icon file. And then in this header file, we're using this identifier that we configured in the resource file, and we give it an integer number. So in the code, when we want to use that, we have to use this macro called make integer resource, and we tell it the identifier, and it slaps the number 100 in here from and that's how all of these resources are used, except for this one is not an integer resource. It's just a text identifier sound menu. So we have to put it in double quotes because it's a string text identifier. It's not an integer identifier like all these other guys are. The menu items themselves are integer identifiers, but we don't have to refer to them in the program like that. We just refer to them. Well, we do in here. We refer to them like that, with the same macro. Okay. And basically, it's all this extra code with. Let's see how I did this. Yeah, I did this one the shorthand way too, where I did all of it in one line for each one of the. This is the X value of the screen. This is the Y value of the screen, where we want to position this window and make it to where it's in the middle of the monitor. And I don't think there's another piece of code that we can use to close the window by doing the escape key, but I don't think it did in this program. and somebody's trying to call me on my phone, and they're just going to have to wait because I'm on a stream right now. I can't talk to people when I'm on the stream. Okay. And besides the extra stuff that I showed you about the resources, the code is the same as the other one. It's just got all these other extra things in it to make it be able to play sounds and everything. So we'll run this one and show you what it does.
Creating window.
I hope you was able to hear that. If you didn't, when this thing started up, and I don't know why my antivirus program thinks things that I make in Visual Studio are
creating window.
Okay, why is it doing that? I hate it when
creating window.
Okay, so when the window gets created, it plays that sound, creating window. Right off the bat, see the mouse cursor? It's a crosshair. It's like a stylized looking crosshair. It's pretty cool looking. The icon in the upper left corner of the application is that T3DX icon. You can see it a little better down here on the taskbar. And we have a menu. So if we go to the File menu, and I got a notification that my OBS disconnected and reconnected. I don't know why it does that. That's annoying. But it's reconnected. I think we're on still. But if I go hit the File menu, then we got the Exit menu that pops up. And if I do Exit, it shuts the program down.
Creating window.
So we'll start it up again. Another thing too, if you hit the Alt button, watch what happens up here in the menu. On certain menus, you'll get that hotkey indicator. So if we want to open the File menu, we can do it just by pressing F. And if we want to exit, we can do it by pressing X to see the X is underlined. But if we want to go to play sound, then we have to go back to File. It won't let us do that. The P we hit the P key on the keyboard and it pops open this menu. And here's where we're playing the sounds at. So here's the Energize sound. And I don't think these had the hotkeys coded in. Wow, that was loud. That was the Energize sound. Here's the Beam Me Up Scotty sound. Dear Lord, I didn't make these sounds. Somebody else did. Engage the teleporter. Are you ready? Hang on to your ears because this is going to hurt. The Quantum Warp Teleporter. Ouch. That was deafening. Then last but not least, the Help menu, and it just says About, and if you click it, the About sound menu window comes up with that exclamation point icon. It says Menu Sound Demo. and an OK button we can click on to dismiss the About window. And there you have it. I didn't program in the escape key to do the exit, so we can click on the X, or we can make use of the menu and exit the application. That was a pretty cool application. I think I'll leave my whole desktop displayed there for the moment. Let's see. We've been live for an hour and 3 minutes, so I'm probably going to go to about 9 o'clock and then I'll end it. But I just wanted to show some more cool things with Win32 programming. This one is a direct draw initialization demo, and this is using the old version of DirectX. It's using DirectX 7, which is what it was called when it was actually DirectX 8. Yeah, that's Microsoft for you. It's confusing. But this is an old version. I just wrote this code the other day, but it's using the old direct draw stuff where you had to not only have the direct draw object, but you had to have a primary surface. You had to have a back surface to do double buffering. You had to have a palette for colors, because I think this one is only using a bits per pixel of 8. So it's only using like 256 colors. That's kind of weird, but that's what it's doing. See, 256 colors, palettes. And you had to have a surface description. This is another structure you have to fill in to tell it to do different things. And you had to have this direct draw blit effects that you had to fill in, and a direct draw surface capability structure that has a ton of variables in it you had to fill out. It's crazy stuff. And these are variables to do for general clipping, but I don't know why the person included that code in there, because this particular program doesn't do any clipping. It doesn't do any graphics at all. It just initializes a direct draw window with that'll support just 256 colors, and it's like the window is 640 by 480. And I used my screen centering code on it, and it uses the WinMain and the Robert F. Butler thing. Does all that. And this is what it looks like. And there goes my, I don't know why it keeps doing that. It's just, I'm going to have to, that was my antivirus program doing that. I don't know why it thinks that a simple little program I create myself in Visual Studio is some kind of virus. That's crazy. I'm going to tweak the settings. They're obviously way too high. But see, this is all it does. It just makes a 640 by 480 window, and if you were doing any graphics in here like GDI or doing actually DirectX drawing stuff in here, it would only be 8 bits per pixel, 256 colors. You'd be very limited in the colors. And I think this one uses the escape key to exit. Yes, it does. So let me show you here's what that code looks like. And there's two parts to that code. And I think it's using the key down macro. So this defines a macro, sort of like a function. So like a predefined function. And then down here in the main game loop that executes once per frame, we're actually calling that predefined function and sending it the VK escape key. So it says if they clicked on the escape key, send this message to the main window, and the message is WM close. So whenever you send a WM close to the window procedure, as you can see, there's not a WM close to handles. When it just knows that when it gets a WM close message, it goes to this destroy message and goes post quit message, boom, and then the program shuts down. That ends everything. And this gets called right before that happens and releases the direct draw object that we created earlier. Or this gets done automatically anyway when the program is shut down by the post quit message, if that makes any sense to you. I know if somebody's watching this and they're not particularly a programmer or interested in this kind of thing, the music's getting a little bit loud. If they're not interested in this kind of thing, then it's kind of boring, but very interesting to me. I really enjoy doing it. But this kind of stuff is what you have to learn before you start doing any game programming. Let's see. Let's see if I get some. I think I've got some other very interesting Okay, here's this is a program that uses OpenGL, and all it does is create a window, but it doesn't use, as you can see when I scroll through here, it does not use WinMain. It uses just a regular main function like a C program. but it creates a window using GLFW, which I said abstracts every bit of that Win32 code you seen earlier to create a window. That's using the WinMain and the window procedure and the creating the window class and then registering it and then creating the window from all that and showing it. GLFW does all that for you. We probably could have used GLFW to do those other examples, and it would have probably worked the same. I don't know, probably wouldn't have worked with the resources because I don't know enough about GLFW. All I know how to do with GLFW is just create a plain window, not one with resources like menus and that'll play sounds and stuff like that. So I'm sure there's a way to do it in GLFW, and it's probably easier than Windows, but I haven't learned how to do that with GLFW. I've only learned how to do just creating a basic window to draw something in with OpenGL. And this uses the modern OpenGL 3.3 that uses shaders and vertex shaders and fragment shaders, which are little bitty programs that you can use. And what this actually does is it puts a certain color onto it draws the vertexes in certain positions and then assigns a color to them on the GPU, on the video card, the graphics processing unit. And this has a lot of code in it. It's like almost 200 lines of code to create a window and draw a triangle in it. And this is what I'm not going to go and explain every bit of it because I would be here longer than the 15 minutes I have left. But this is what it looks like. And of course my stupid Avast tries to interfere again. This is the window created by GLFW, and it automatically uses that default IDC application icon, and you can see it down there in the taskbar, and it does an orange triangle on the screen inside that window. Let's see. Let me see if I can remember. Trying to remember how to. I think it do it right in the shader. Yeah. So if we do this, it won't be an orange triangle anymore. It'll probably be closer to green. What about that? Not quite a true green because we get a little bit of blue in there because we had 0.2 of blue in there. So let's make that no blue and make it all green. We can quit doing that. Make it 1.0, , 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1.0, 1. So this is like red, green, and blue, and it mixes them together. And this one right here is the transparency alpha channel, and one is completely opaque, not transparent. Excuse me. This will be extremely green, fully green. And I think, yeah, I did the escape key code in this particular. We'll see what the escape key code looks like in this one. I don't think it's a macro like to the other one. Process input, that's a function called process input. It's probably down here. There it is, process input. So this app, it executes this every frame, and it's checking to see if, and see who's doing this. WLFW, the window creator. It also responds to key presses. So if the escape key is pressed, GLFW set window should close to true, and the window closes. Kaboom. This function here gets called if you resize the window. So if you resize the window, it adjusts everything inside the window. Pretty cool. So that's OpenGL stuff. There's a lot more to learn about OpenGL, and there's a lot to learn just to do a triangle on the screen, because you had to learn all of the vertex buffer object and vertex array object, how it uses these vertices to actually, these are the points of the triangle. This is the left point, the right point, and the top point. And it's really weird that it's only using the numbers 1 to 0 to do that. And it translates it into the screen coordinates. It's kind of bizarre, but then you have to compile the shaders and then link the shaders into a shader program. And the vertex shader and the fragment shader are the only two that are required to get anything on the screen. There are other shaders. I think there's a couple of more geometry shaders and some other tessellation shader or something like that, but they're not required. They're optional things that you can do to do advanced things to the vertices and things you're drawing on the screen. It's pretty complex stuff. But this is how you set up GLFW. You tell it you want the OpenGL core profile, which is the modern one where you use shaders. And the very first one, I think, was 3.3. Anything before that is immediate mode, old style OpenGL. That's deprecated. Shouldn't use it anymore. You probably could, but you shouldn't. And there's the GLFW create window function. Then there's where you make the current window, make it the window of the current context, meaning that's the one you want to show. And I forget what this GLAD stuff does. I think it handles I think it handles the OpenGL function names, makes them normal looking where the parameters are not reversed, because C++ has has a habit of doing that and reversing your parameter lists, the order they're in for the operating system, but that keeps them, I think that's what it does. I'll have to read that. I'm not a complete expert at this stuff, so take a lot of I say here with a grain of salt, particularly. Okay, got about 7 minutes left. I don't think there's anything else in here that's interesting. This is how you clear the background screen with these two calls. This is OpenGL stuff right here. And then some more. We tell it to use the shader program. We link the shaders into, and then we bind the vertex array object, which has the information in it about the triangles we want to draw. And then this one actually draws the triangles. Draws the triangle, one triangle. And this is just checks for events. That's part of that event message handling thing. It like tells Windows, hey, here's the event, and it sends it to the window proc. So it creates one. GLFW probably creates one in the background for us that looks similar to what I did in the other Win32 program you saw earlier. And then they have to swap the buffers to actually show the triangle in the window on the screen. Kabam, that's what that does. And then when you shut the program down, it goes and cleans up after itself. It blows away the vertex array object we created, and then the vertex buffer object we created it's holding the information about the shaders and everything, and blows away the shader program that we linked all that stuff together in. And then you have to terminate GLFW. And then that returns to the operating system that everything was okay and the program has gone away. And there you go. That's a little foray into Win32 programming and C++, along with a little foray into OpenGL and DirectX. Hope you enjoyed the show. And my screen's probably going to look weird because I stream and do what I'm doing on my stream all on the same computer, so I got to open up OBS and you're going to see that. There we go. So maybe if I maybe if I do this, then you can't see my screen anymore. There we go. You can't see the screen. Okay. So I enjoyed it. Hope everybody enjoys watching, and leave me some feedback. If you want to see some other kind of programming, I can do Python programming, and also do JavaScript programming, making games for the web browser. I'll probably look at some of that tomorrow. So come back and enjoy that. This is Covering Fire. saying so long.